In this video, we're going to take a look at solving triangles that are non-right angled, and to do that we're going to need a new tool called the Sine Law. Now, in the past we've been able to solve triangles, and to solve a triangle means to find all the angles and all the sides. For right-angled triangles, and we were able to use SOHCAHTOA, sine, cosine, tangent to do that. But what if it's not a right-angled triangle? What if instead it's just some triangle ABC where I know some information, maybe a couple sides or a couple of angles and a side, and I need to be able to find all of the angles and all of the sides. So first of all, we're going to need to use angles, but we're also going to need to use side lengths. So across from this angle A will be side A. And we'll do the same thing. Across from this angle B will be side B, and across from this angle C will be side C. And I just use capitals and small letters. And it turns out that there's a ratio between, an equivalent ratio between angles and their opposite sides, such that if you took the sine of angle A and compared it to the side length of A, it would be exactly the same as if you took the sine of angle B and compared it to B, and that's exactly the same ratio as sine from angle C compared to side C. And this is known as the Sine Law. And the Sine Law is useful in solving certain triangles. And you can use this Sine Law to find missing sides or angles, but only if you know certain things. So if you have a triangle in which you know an angle, and then you know, so there's an angle, then you know a side, so you'd have to know this particular side, and then another angle. So in a row, an angle, a side, and an angle, then you can use the Sine Law, and you can find other pieces of information. In fact, you can use this one to find missing sides. If you have a triangle, and you know an angle, and then another angle, and then a side, so an angle, and then a side, you can use the Sine Law, and that will also help you find missing sides. And finally, if you have a triangle, and you know a side length, another side length, and then an angle, you can use the Sine Law to find missing angles. And the order of these is quite important. So if you know two angles and the side in between, we call that ASA. If you know two angles and then the following side, we call that an AAS triangle. These ones are especially good with the Sine Law. If you know two sides and then an angle, it'll work, but it's a little more complicated when we're working with this type of triangle. But most of the time, we can find the missing angles for those triangles as well. So let's get some practice in and actually solve a few examples of this. So those will be the instructions. In our first example, we just want to solve triangle ABC, and here's what triangle ABC looks like. And so I need to find all the missing angles and all the missing sides, and you can do this in any order you want. So let's go ahead and do one of the easiest things, which is to find this missing angle A. And angle A would have to be, well, all the angles in the triangle are 180, so if I subtract away 110, I'm left over with 70, and I subtract away the 40 for angle B, I'm left over with 30 degrees. So we can use some basic principles of triangles, such as the sum always has to be equal to 180 to calculate this angle. No Sine Law needed yet. However, to calculate and in this case I've got angle, angle, side. To calculate some missing sides, I am going to need the Sine Law. So let's state it. Sine of A, which is 30 degrees, over A, which is this missing side here, is equal to sine of B, which is 40 degrees, over B, which is 16, equals sine of 110 degrees over, that's C, angle C, over side C. And so you can see I know one complete ratio, this middle one, and there are two other ratios that I don't know in entirety. So I will use the complete ratio of sine 40 degrees over 16. I will use that ratio to help me calculate this a value first. So now I'm solving for one of the sides, and I do that again by using one of the completed ratios and one of the ratios that I don't know all of the parts to. I know one, but I don't know both parts to it. And to solve this, I essentially multiply both by 16a, which essentially results in cross multiplication. So I get a sine 40 degrees equals 16 times sine 30 degrees, and then I divide both sides by sine 40, and I have to calculate whatever 16 sine 30 degrees over sine 40 degrees is on my calculator, and I get 12.4. Please double check that you can type that in on the calculator and you get the same solution that I did. To find c, I use the other two ratios, namely these two. So let's do that work in green. I have sine 40 degrees over 16 is equal to sine 110 degrees over c. Cross multiplying gives me c times sine 40 degrees equals 16 times sine 110 degrees. And that means that c is 16 sine 110. Both sides get divided by sine 40 degrees. And so I'm going to need to divide this by sine 40, and I get a c value, and please double check that you get the same thing, of 23.4. And this was 30 degrees, so that's the smallest angle. A should be the smallest side. So is 12.4 the smallest side? Okay, well, it looks like it's smaller than 16. And 40 will result in 16, that's the middle, and then the biggest angle should result in the biggest side, and that's 23.4. So a quick little check there. Everything looks like it's okay. Let's move on to another example. So in this one, again, the instructions are to solve triangle ABC, and there's triangle ABC. It's nice to think about, well, there's your angle B, and there's your angle C. This is side C over here. Of course, this is sides A and B. And I can't figure out any of the interior angles because I only know one of them, so I'm going to jump straight into seeing if the sine law will work. So sine A over A is equal to sine of angle B over 6, that's B, and that's equal to sine C over C. So as long as I know one ratio, you can use the sine law to help out. So I know this is my completed ratio this time, and I'll be able to hopefully figure out these other ones. Start by doing these first two, and I'll do those in black. Start by using these two, and if you do that, you get sine 80 degrees over 8 is the same as sine B over, in this case, 6. And the variable is the b, so that's what I want to solve for. So I multiply both sides by 6, so I get 6 sine 80 degrees over 8 is my sine b, and that means grabbing my calculator to figure out what this is as a decimal place, I get about 0.039. Please grab your calculator, pause the video, double check some of this work, make sure it's actually correct. And then to calculate what the angle is, I have to use the inverse sine button on the calculator. And again, double check that you get for angle B the same as I did, which is 47, we'll round to one decimal place, 0.6 degrees. So this one up here is 47.6 degrees. Now, inside of a triangle there's 180 degrees, and I've used up 80, that would leave me with 100, and I've used up 47.6, so that would leave me with 52.4 degrees. So I actually automatically know what angle C is. It's 52.4 degrees. Now I can go ahead and I'll use this first one and this last ratio and do those in green. Sine 80 degrees over A, and now I can use the C value that I calculated of 52.4 degrees over C and calculate this missing C. So we'll do it like we did in the last by cross multiplying, and then dividing both sides by sine 80. I would very much think that it would be a good idea to use the storage buttons in here. In fact, you could call this B. That would make a lot more sense than calling it A. You could call this C, and then you can just type in C using the storage buttons here when you're going ahead and calculating these sorts of things, and then you don't lose any decimal places of accuracy, and so you'll get a side of C, which is 6.4. And again, you can double check and see that this makes sense. If this is 52.4 degrees, the smallest angle should give us the smallest side, the next largest angle should give us the next largest side, and the largest angle will give us the largest side. So that looks like it is working perfectly. Okay, there is a scenario where this does have some quirks, so let's take a look at one last example.